Hi everybody, I hope all of you are doing great. So welcome back to the channel again. We are going to continue with DP playlist, but before everything, let me first apologize, right? It has been a long time since I've uploaded anything on YouTube itself, and that's just because I've got busy somewhere else, right? Apart from my teaching, right? That is, of course, many of you already know from my community post, right? That I've joined Swiggy as a backend software development intern, getting to learn a lot of things, right? When you are in these big companies, you get to know how they are building softwares, how they are handling problems, right? Business problems, technical problems, and all these kinds of things, right? They're building solutions for this, and they are building basically, the whole process of a software being made, the whole process of a code being contributed into a big project. It's a very good thing to experience, right? And experiencing that only, learning a lot, right? Have to learn more, right? So that is the phase I'm going through right now. But yeah, we'll share my learnings if you all want, right? Once I get confident, right? Once I get to know everything from A to Z, right? But yeah, so in the meantime, of course, this DP playlist is going on, right? I'll not move forward to any other playlist or any other content before completing this DP playlist. This is the thing I'm working on right now. So yeah, and why I was not able to upload, like, of course, I'm teaching as well, and I'm doing internship at Swiggy as well. So everything is taking time, and I don't want to upload content just for the sake of uploading the content, right? Because at the end of the day, before recording a single problem, I do a lot of research behind that problem, so that whatever I'm telling you here on this channel is the final source of truth you're going to refer, right? You don't have to go somewhere else to get to know the complete thing, right? This is the final thing which I'm trying to prepare, right? And basically my videos are long, of course, but if you watch that complete video, you will not be like going through anything else for that particular topic, for that particular problem, right? So yeah, so didn't want to upload just for the sake of uploading, right? Have collected myself again, so we'll be working on this DP playlist. And yeah, let's get started with this next problem in the DP playlist itself, which is delete operations on two strings. Let's read the problem. Let us see what this problem is saying. Given two strings, word1 and word2, return the minimum number of steps required to make word1 and word2 same. Basically, two strings are given to you. You have to make both of those two strings equal to each other. Simple. And you have to take some steps in order to make those strings equal to each other. What are those steps? You have to return the minimum count of those steps, minimum number of steps required to make word1 and word2 the same. What are those steps? In one step, you can delete exactly one character in either string. Basically, if you want to take a step, you can delete a character in either of the strings. So you can see here SEA and EAT. Right. If you ask me what I'll do, I will delete a S here and I will delete the T here. In both the strings, I'll be left with EA and EA. Right. So, and both of them will become the same. So basically, I've taken two steps: delete one character from first string, delete second character from the second string, like another character from second string, and after two deletions, you'll be getting both the strings as the same words, right? Okay, so I hope the problem is pretty clear to you, right? You can delete the character from anywhere. If I want to delete this T, I don't have to delete anything else. I can directly delete that particular character. So you can delete as much as you want. You can delete whatever you want, right? It's just that the count of characters you're deleting in any of the strings, the total count, you have to minimize that so that both the strings become equal. Sometimes it might happen that, A, B, C, for example, this is another first string. Let's say R, T, Y. This is another string, right? So what is happening here? None of the characters are same. So can I say that I will delete all the characters and both the strings will become empty? In that case, total 6 characters I'll have to delete, right? And in this problem and this particular test case, I'll have to delete 6 characters, right? So let's not rush forward. I hope the English of this problem is clear to you all. Let's try to understand on this board that what this problem is actually saying. Then look at the recursive solution. Then look at the memoization solution. Then look at the tabulation solution, the normal drill we do for a particular question. So let's get right into it. So we are on the board again, and let us see some test cases. I've drawn some test cases here. So for example, these are the two strings which I want to make equal by deleting characters in both of them, right? So what I can do is, you can see that AER is a particular string which is common in both, right? So I'll delete a P from here. I'll delete a Q from here. Whatever is left, you can see AER is left in the first string. AER is left in the second string. Both of the strings have become equal, and the characters number of characters I've deleted is 2, and this is the minimum number of characters you are going to delete in this particular test case. So 2 is the answer for this test case. Let's talk about this test case. Both the strings out of the box are equal to each other. This means that I don't have to delete anything. This means that 0 characters we want to delete. You can see in this particular test case, delete you can either make xb xb, or you can make ab ab. So either you can delete both the x, or you can delete both the a's, right? Whatever you want to delete, you have to delete at least 2 people, right, to make both of these strings equal, right? And 2 is the answer for this test case as well. In this particular test case, you can see none of the characters are common in both the strings, right? So what we have here is basically deleting both the strings completely, entirely, both the strings entirely. And what we are going to do, we are going to simply say that yes, basically number of characters we want to delete is 6, like total 3 plus 3 6, and that is the answer itself, right? So this is the problem statement, and this is the so you can say how the problem is going around and what we actually have to do, right? Let us look at the approach for this problem and then move forward. So for example, just like the normal drill, we are going to take a test case, we are going to build the whole recursive tree for that particular test case. So let's say the first string we are having is APER, and the next string we are having is QAER. We already know the answer to this test case, so it would be better to see the whole recursive tree as well, right? So at one point of time in recursion now, I will look at only the first characters of both the strings. So look at the first characters of both the strings. Or in other words, I'll look at the ith character here and the jth character here, right? So A, Q. Are both of these two characters equal? No, they are not equal. This means that I have to remove one of them, right? I'll have to remove one of them. This is the condition, right? Because both of them cannot stay alongside each other at one point of time, right? That is the thing, right? Because both of them are not equal. They cannot stay together, right? Only equal characters can stay at the same positions, right? So A and Q cannot stay together. I'll delete, let's say I'll make a call. I'll make another call. In one call, I will delete this A. So the remaining string here is PER. This is string 1. I have not deleted Q, so QAER, AER. And in another call, I'll have A, I'll not delete A, I'll delete Q, right? So APER, I'll have A, I'll delete Q. So AER is remaining here, right? Okay. So let's explore this test case now, this particular side here. So here you can see P and Q are not equal. So any of them have to be deleted, right? I have to delete any of them. So let's delete, I'll make of course 2 calls. I'll make 2 calls. So in first call, I'll delete P, and in second call, I'll delete Q. So let's first delete P. So ER, and here you can say QER will be there completely. QAER. In the second call, I'll not delete P, I will delete Q. So PER will stay as it is, and AER will go forward. Correct? Let's go slow. Let's understand everything very slowly. These things are happening again and again. So if it's not clear right now, it will be clear in some moments, right? So don't worry. Okay. Okay. ध्यान से देखना. So Q and E, both of them are still not equal, right? So I'll have to delete either of them. So let's delete either of them. So in the first call, let's say I'll delete the first character of S1. So I'll delete, let's say E. So remaining S1 is R, and S2 is as it is, QAER. Here I'll delete Q, right? So ER and QAER will be as it is. Correct? I have deleted, sorry, I have to delete Q, right? So AER will go here. So AER will go here. Correct? I hope it is clear. Now, still you can see one problem is there. One problem is persisting, that R and Q are not equal. So I'll have to delete either of them, right? So let's make, so basically in recursion, you can observe now that we are trying to get as many possibilities as we can. So first I'll delete R, and in second call I'll delete Q. So if I delete R, the first string will become empty. Second string is QAER as it is. And if I do not delete R, and I delete Q, so AER will go as it is, right? So now look at this particular case. Look at this case. Let's hold on. Let's look at this case. We are having an empty string, and we are having a string which is not empty. QAER. To make both of these two strings equal, I only have to take delete operations. And if I'm taking delete operations, can I say if I delete all the characters in the second string, that is the only possible way to make these both of these two strings equal, right? So this is one of our base cases. What is the base case? If any of the strings becomes empty, right? If any of these strings become empty, whatever is remaining in another string is what is the number of moves you have to take in order to make both the strings equal, which is make both the strings empty strings, right? So from here, I'm going to return what? I'm going to return here 4, right? So if I take 4, if I do 4 delete moves, which is deleting everything here, I'll be able to make the strings equal. I hope this base case was clear to everybody. Okay, so 4 is returned from here. Let's discuss this particular case. R and A are not equal. So what will happen? I'll have to delete any of them. So first call I'll delete R, second call I'll try to delete A, right? So if I delete R, empty string, AER. If I delete A, R is remaining here and ER is remaining here. From here, we already know what is going to be returned. It will be 3 because if a string has become empty and another string is having some characters, I'll have to delete all those characters in order to make both the strings equal. This is already empty. This is having 3 characters. Only operation I can do is delete operation. So I'll have to delete whatever is this particular string having. So I'll delete all the characters in this string to make both of these strings equal. So 3 will be returned from here. So 3 will be returned from here. You can see E and R are not equal. So in first move, only the first characters I'm looking at. So in the first move, I'll try to delete the character from S1. So empty string and ER. In the second move, I'll try to delete. In the second option, I'll try to delete E. So R and R will be remaining. Now look at these cases very carefully, right? Very important cases. So empty string and this is having something. So whenever a string becomes empty and another is non-empty, we are going to return what? Whatever the number of characters are there in the non-empty string. Just like all these cases, right? So I'm going to return 2 from here. By doing 2 moves, I'll be able to make both of these two strings equal. That is what I'm trying to say. Correct. Look at this particular case. This particular case is now has happened for the first time that the characters are equal, right? Till now there was no case when characters were becoming equal. Now for the first time there's a case when both the characters are now equal, right? So if both the characters are equal, I'll say that just remove both of these two characters because they are equal. I'll not count them. Why to count them? I'll keep them, right? I'll keep them and just ask for the answer from the remaining strings, right? These two characters are equal. They are not going to make any difference because they are equal, right? I can have equal character at the end of the day. I want to make both the strings equal, na? So what I'll do, I'll ignore these characters and I'll ask for the answer for the remaining strings. So empty strings, empty string, right? So because only RR is remaining, the remaining strings in both the cases is empty string only. But I hope you understood, right? If both the first characters of both the strings are coming out to be equal, for example, you are having a case A, B, C, D, and let's say A, P, Q, R, right? This A and A are equal, right? So the answer does not depend on A and A. It depends on B, C, D and P, Q, R, no? B, C, D and P, Q, R, right? So whenever both the characters come as equal, I'll ignore them and I'll ask for the answer for the remaining strings. In this case, they're empty. If both the strings become empty, I'll have to do 0 moves. So 0 will be returned from here. Here as well, 0 will be returned from here. Right? So 0 will be returned from here. Now, look at this very carefully. If I delete R, I'll be having 2 plus 1 moves to make both the strings equal. First move to delete R and then 2 moves to make both of these two equal. I'll make it slow. So, full focus. Dekho. If I delete R, I've taken 1 move. Yes. And 2 moves to make both of them equal. So, total number of moves if I delete R is 3 in order to make both the strings equal. Right. Correct. Right. Okay. Great. If I delete the E here, I have taken 1 move to delete E and remaining strings are R and R. They are taking 0 number of moves to become equal. So 0 number of moves to make the remaining strings equal and 1 move because I deleted this E. What is the minimum? 1 plus 2 or 0 plus 1? That is definitely 0 plus 1. So I'll return 1 from here. Can you see how beautifully? Look at this test case particularly, R and ER. R, and if I delete this E only, both the strings will become equal, and that is what we are returning here. Correct? So I hope you are getting the approach to this problem itself, right? I'm going very slow. So if like speed seems a little bit faster, don't worry. We are going to complete the whole iteration. I'm not going to skip through anything. So let's look at everything, right? So ध्यान से देखो. If I delete the R, I've deleted R, so one move to delete R plus three moves to make both of these remaining things equal. Total number of four moves to make both of them equal. If I delete this A on the other hand, I have deleted this A, so one move to delete A plus one coming from above to make both of these two remaining things equal, right? So what is better, 4 moves or 2 moves? That's definitely 2 moves. I'm going to return 2. Let's look at it separately. R, A, E, R. Here, what is the best thing? I will delete these two A and E and I'll have both the strings equal. I have taken 2 moves to make them equal. I hope you are getting this, right? So 2 is returned from here, correct? Okay. From this particular case, what will I do? What will I do? When I delete R, that's 1 move plus 4 moves to make both of these two equal, total 5 moves. When I delete Q, that's 1 move plus 2 moves to make both of these two equal. What is better, 5 or 3? 3 is definitely better. 3 is going to be returned from here. Okay. All right. So 3 is returned from here. Let's see what will happen here. Right. Let's see what will happen here. So this is one of the options. Let's explore this option, this particular option. I want to make ER and AER equal. So you can see ER with E and A are not equal, right? E and A are not equal. So what I'm going to do is I'm going to call, right? Let me just make some space here, right? Just make some space here. Okay. Of course, this arrow is like this. Okay. So let's see. If I delete this E, right? Let's do the first call where I'm deleting the E and the second call where I'm deleting the A. So if I delete this E, the remaining strings are R and AER. If I delete this A, the remaining strings are ER and ER. Correct? If I delete this A, ER and ER are remaining. Let's see. Can you observe the overlapping problems here? R, AER, R, AER. I've already calculated the solution. I don't have to make this tree again. That is memoization, right? Why should I make the tree again when I've already calculated to the same test case? Can I directly return whatever I returned before? Look at this particular test case returned what? This returned 2, right? This returned 2. So I will also return 2, correct? 2 will be returned. This plus 1 I added because I deleted Q now. But actually this particular thing returned 2. So I will also return 2. And that is definitely true. To make both of these two equal, I will delete A and E. And both the strings will become equal, right? I hope you are able to get it, right? So ER and ER. Let's explore this particular side here, right? And total number of moves here is, if I delete R, right? Basically, if I delete E from here, so 1 move to delete E plus 2, right? Let's explore this side, right? So 1 move to delete A, and how many moves to make both of these two equal? Let's see. E and E are already equal, so I can ignore them. Remaining strings are what? Remaining strings are R and R. So R and R are remaining. Draw it correctly. R and R. R and R have already calculated, and R and R returns 0. So I don't have to make a tree again. No, I'll directly return a 0 from here. Correct. Let's return a 0 from here. I'll return 0. We did not delete anything in this point, right? At this particular stage, we did not delete anything. So I'm directly going to return 0 here as it is. I'm directly going to return 0 here again, right? So 0 will be returned here. So 0 plus 1. Total number of moves, if I delete A to make the remaining strings equal, is 0 plus 1, which is 1. What is better? To make both of them equal, should I delete E and then 2 moves, which is 3 moves? Or should I delete A and then 0 moves, which is 1 move? Definitely 1 move is better. I'm going to return a 1 from here. I hope you are getting the whole solution for this problem itself, right? So this particular case, what will I return? I will simply return, what is the, so if I delete E, 3 moves to make rest of the things equal. I've deleted E, so total 4 moves. If I delete Q, 1 move to delete Q and 1 move to delete the rest to make rest of the string equal, right? So 2 moves in total, right? You can see here clearly. If I delete Q and A, ER and ER will become equal, right? So minimum is what? 1 plus 1, which is 2. So I'm going to return here a 2, right? This everything is now making sense, no? Right? So let's explore more, right? P, let me just draw this test case particularly here so that we don't have a bad diagram, right? Of course, recursion is taking time. You can skip the recursion part to the recursion pseudocode part, right? If you have gotten everything, but I'm going to complete the recursion here itself, right? I'm not going to leave any doubts or anything remaining, right? This is not a live lecture. This is a recorded video, no? So for recorded video, I have to complete everything, right? So P A, right? Okay. If I delete P, both of them are not equal. So this means that I have to delete any of one of them. So two calls will be there. So the first call is when I'm deleting P, second call when I'm deleting A. If I delete P, remaining strings are what? ER, S1, AER from the S2. A is intact. If I delete A, so PER and ER. Correct? Correct. Okay. ER, AER I've already calculated. Overlapping subproblems. You can definitely see this is dynamic programming. We have already calculated this, no? So I'm not going to calculate this particular test case again. I'm simply going to return what? I'm simply going to return whatever we return. This returned 1, so I'm going to return 1 itself. Without asking any questions, I'm going to return 1 because we have already seen how it is returning 1, no? So I'm directly going to return 1 from here. PER and ER, we have not calculated this test case particularly, no? So let's calculate this test case. So two calls will be there. P and E are not equal, so two calls will be there. First, I'll try to delete P. Let's delete P. So ER and ER. Then I'm going to try to delete E, right? So PER and only R, correct? ER and ER, definitely we have already calculated this test case. It returns 0. So we are going to return a 0 from here. Let's return a 0. Return 0 here. I'll return a 0. But this particular test case, let's see, P and R are not equal, right? So I have to delete either one of them. So let's delete a P first. So if I delete P first, so ER and R are remaining. The remaining, if I delete R here, so PER and R, empty string, I've deleted R. So E and R are not equal, right? E and R are not equal. Let me zoom in a little bit. So E and R are not equal. What am I going to do now? I have to make choice, no? I have to make a choice. So if I delete E, R and R are remaining. If I delete this R, ER and empty string is remaining. R and R, we have already calculated, it returns 0. So I'm going to return 0 here. ER and empty string. This is a case which was similar to this case, no? This particular case here. One of the strings has become empty and one of the strings is non-empty. So what we are going to do? What are we going to do here? We are going to return what is the length of the remaining string. So one is empty string, one is a string which is having some characters. To make them equal, I can only do what? I can only delete. So I have to make both of them empty strings. So 2 will be returned from it. Now let's see what is going to happen. 0. If I delete E, one move, plus to make rest of strings equal, that's 0. If I delete R, that's one move, plus to make rest of the strings equal, that is two moves. What is better, 1 or 3? 1 is definitely better. We want the minimum answer. So we are going to return what? We are going to return a 1 from it. I hope you are getting the solution itself, right? This particular case, PER and empty string. What are we going to return from this case? One string is empty, one string is full. Whatever the length of the full one is, that what we're going to return from here. If I delete P, that is one move, plus the remaining strings are getting equal in one move. If I delete R, that is one move, plus remaining strings which are getting equal in three moves. So 2 or 4, what is better? Definitely 2 is better. So we are going to return 2 from here. 2 is returned from here, right? So now let's see. If I delete P, one move plus 0 to make rest of the strings equal. If I delete E, one move plus two moves to make rest of strings equal. Which is better? Of course, this case is better, no? So I'm going to return what? I'm going to return a 1 from here. Let's return a 1 from here. 1 is returned from here. So 1 is returned from here. Now let's see. If I delete P, one move plus 1 to make rest of strings equal. If I delete A, one move plus 1 to make rest of strings equal. Two coming answer from both the sides. So I'm going to return what? You can see now, if I have to delete P and A both in order to make, you can say, the overall answer. So let's see, we are going to return a 2 from here. So I'm going to return a 2 from here. If I delete a P, one move plus 2 to make rest of them equal. If I delete a Q, one move plus 2 to make rest of them equal. So 3 overall we are getting. So we are going to return a 3 from here. But 3 is not definitely the answer. 3 is not the answer, na? Let's explore this side. If I delete Q instead of A, because AER is the string we are getting, right? If I delete Q instead of A, let's see what we are going to get. Look at this, A and A are equal. A and A are equal. We don't want to delete, like, why do we want to increase our number of moves? So we are not going to delete anything. We're going to call for what? We're going to call for the remaining strings. So PER and AER. Have we possibly calculated? Yes, we have already calculated this answer. We don't have to draw the whole tree again. We've already calculated this answer. So dynamic programming is not only optimizing the time complexity in the solution, but also the time complexity of the video itself, right? So we don't have to draw the whole thing again, right? So we are going to return what? Whatever was returned from here. What was returned from here? It was 2 which was returned, right? So 2 is going to be returned here as well. And A we did not delete. So I'm not going to add a 1 here. Like the blue ones which I'm adding, I'm not going to add here because we did not delete any of them. They were equal. So I kept having both of them. So I'm going to return 2 here from as it is, right? So now let's see what is the overall answer, right? So okay. So 1 move to delete A plus 3 moves to make rest of them equal, or 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 1 move to delete Q plus what? 1 move to delete Q and 2 moves to make rest of them equal, right? How are we getting 2 moves? Let's see. PER and AER. Okay, have I done some mistake here? So let's see. Okay, so mistake I found, basically I want to skip both of the characters, A and A both, na? So here I should not write A here, right? I should write PER and ER here instead of A, right? So this is a particular mistake I did here. So if you were able to figure this out, then great, right? So PER and ER, have we calculated the answer for PER and ER specifically? PER and ER, PER and ER, yes. So PR and ER returns a 1. PER and ER returns a 1, right? So this will return a 1 from here. We're going to return a 1. So देखो, A and A were equal. So I have to ignore them. What is the remaining strings? PER and ER. Instead I write AR here, right? Earlier. So that was wrong. So 1 is going to be returned from here. This person will automatically return 1 from here, right? And 1 moved because I deleted Q. So what is better? Deleting 4 people or deleting 2 people? 2 people is definitely better, so 2 will be returned from here, and this is how the recursion will work. So I hope you are able to understand how the recursive tree is this tree will go ahead, right? I've drawn the complete recursion tree, and this is how actually it will happen in the code as well, right? Let us look at the recursive pseudocode for this and then move forward in the video. For recursive pseudocode, it is pretty simple. Basically, we are going to write a recur function. We are going to write I pointer and j pointer. I'm not going to actually break the strings. If you have watched my previous videos, you will understand that I'm not going to actually break the strings, right? I will only say that I and j, right? I will take these pointers, and these pointers will help me to point to a particular character which I'm going to compare, right? So, for example, in this particular case, right, 0th characters were getting compared. In this particular case, 1th character of first string was getting compared with the 0th character of the second string. So I and j pointers will be used in order to compare, in order to break the strings, right? Of course, S1 and S2 I'll pass here, both the strings, right? Now what are the conditions? So first, let's write the base cases, right? So if both the strings become empty, basically I is equal to S1 dot length and j is equal to S2 dot length. Both of them are having nothing remaining. So I'm going to return what? Return 0, right? If somehow I is equal to S1 dot length, but j is not equal to S1 dot length, what am I going to return? Return S2 dot length minus j, which is what? The length of the remaining S2, right? This particular case, when I became empty and j was not empty, I became empty, S1 became empty, S2 was not empty. So whatever is the number of characters remaining in S2, that is what I'm going to return from here, right? And similarly for the opposite case is simply if j is equal to S2 dot length, I'm going to return what? Return S1 dot length minus I, remaining S1 string, right? These are the base cases. Okay, so base cases are pretty clear, I suppose. What are the rest of the cases? Basically, the first and the foremost cases, if S1 of I is equal to S2 of j, In this particular case, I do nothing, but I just return what? Recur I plus 1, j plus 1, s1 and s2. Why both of them I've written s plus 1? Because I'm ignoring the characters, right? Dekho, both of them are equal. So I should not get the answer depending on these characters, right? Whatever is the remaining strings in both the cases, on that the answer actually depends, right? So I plus 1, j plus 1, both in this case, right? If both of them are not equal, if ith character is not equal to jth character, I have to make two options. The first option is what? Option 1. Option 1 is what? Let us delete recur. I'll write recur. Let us delete the ith character. So I plus 1 comma j. What is the best answer you're able to get? What is the option 2? Recur for I as it is j plus 1, s1, s2. Deleting the character from the second string, right? And I'm going to return what? Return minimum of option 1 and option 2, right? This is what actually the whole recursion code will actually look like, right? Let us go to the board. Let us write the recursive code. Let us write the memoization code. Let us write the tabulation code. Again, I would like to repeat that coding is not the difficult part on these problems, right? It is actually the approach, how you're approaching these problems, that is what makes these problems difficult, right? So let's get right into the you can say coding part itself, and let's write the recursive code. Let us start writing the recursive solution. So I'm going to create a function here, not in C++, in Java, because we have been studying in Java. So public int recurse, integer I, integer j, string s1 and string s2. Correct? These are the parameters which I'm going to pass here, right? So what are the base cases? If I is equal to s1 dot length and j is equal to s2 dot length, both of the strings, remaining strings are empty basically, return 0. To make the empty strings equal, you don't have to do anything. If one of them becomes empty and rest is having something, s1 dot length, return what? S2 dot length minus j. This will actually return the remaining number of characters in the jth string, right? If j is equal to s2 dot length, if j becomes empty and I is having something remaining, so return the remaining length of the ith string, right? Minus I. Correct? So great, we have been able to do this particular thing, right? Okay, so now the actual cases. If s1 dot char I is actually equal to s2 dot char j, what we are going to return? Whatever the answer for the remaining strings are. So I plus 1 comma j plus 1 and s1 comma s2, right? Now integer option 1, if I delete the ith character, so 1 for deleting the ith character, I don't think that I've done in the pseudo code, but 1 for deleting the ith character plus what is the remaining like what is the answer remaining strings can make. Option 2 is what? If I delete the jth character, so 1 to delete that jth character plus whatever is the cost of making both the remaining strings equal. So I plus j plus 1 comma s1 comma s2. Correct? I hope this is clear to everybody. So option 1 and option 2 are covered. Return what? What is the math.min of both the options? So option 1 comma option 2. Right. Let's write this code here. So return recur 0. I'm going to start from 0 characters of both the strings. Word 1, word 2. Correct. Let's try to run this and let's see if it works. It could have changed their UI. So accepted. Of course, I'm not going to submit it because it will not pass the test cases. It is just a recursive solution. It is not a memoization solution, right? It is not an optimized solution. And of course, the time complexity for this particular solution is 2 raised to the power n, right? If you want a separate video as to how to judge time complexities of questions, you can of course tell me in the comment section. But yeah, this is not optimal solution. We are going to optimize it by doing memoization. And those who are following this playlist, I'm going to directly move to the memoization code. So it's a basic trick, right? Which I've explained many times in this whole series itself. You can find the series in the I button here itself. So you can refer to that if you want, right? If you want to know what this particular trick is. So what I'm going to do, step one is just change the function names to memo, right? What is the dimension of DP I'm going to take? Of course, you can see I'm going to take a 2D DP because there are two parameters which are going to change. So integer array DT, 2D array of course. Here, what am I going to do? I'm going to say if DP of I comma j is not equal to -1, recall, return DP of I comma j. And remember, how do we remember? DP of I comma j is equal to math of min. While returning, I'm going to save it in DP of I comma j, right? And then I'll return, right? So remaining thing is just in the memo function, wherever I've called this memo function, I'll add this array DP, which is another parameter which I'm passing here, correct? And this is how we have converted a recursion code to memoization code. This is as simple as this, correct? So integer DP is equal to new integer word 1 dot length and word 2 dot length. Correct. I hope you are able to understand what I'm going to do here. Correct. Okay. One thing is remaining is I have to fill the DP with -1s so that I know that which case I have not calculated the answer for and which case I have calculated the answer for. So I'll simply do what? For integer I is equal to 0, I less than word 1 dot length, or I can simply say DP dot length I plus plus arrays dot fill ith array. I'll fill the array with -1s. Correct. And instead of calling recur here, I'll simply call what? I'll simply call memo 00 word 1 word 2 and DP array. I'll pass here as it is. Correct. Shall we run this code? And yeah, I think it's here. Okay, accepted. Let's try to submit this now. Of course, we can safely submit the memoization code because it's optimized code and it will get accepted. You can see here, right? So I hope you are able to understand this particular recursion and memoization. Let's write the tabulation code for this problem. Basically, what I'm going to do is create a function called public int memo, tabulation, and I'll simply pass string s1 and s2 here along with the DP array, right? So integer array DP, correct? So basically, what I want to start two loops because the DP is two-dimensional. I'll be writing two loop which are nested loops, and according to the base cases, I'll be starting both the loops from the particular string's length -1s because in tabulation we start building from the base cases, no? So what I'm going to do here, for int I is equal to s1 dot length -1, I greater than equal to 0, I minus minus, and for int j is equal to s2 dot length -1, j greater than equal to 0, j minus minus. I hope it is clear to everybody, right? Now what I'm going to do basically here is let's copy paste this whole code. This is what the trick says, right? This is simple trick here. If you don't know what I'm doing here right now, you have to watch my previous videos and essentially the initial few videos of this playlist in order to understand what is actually happening. And if you really want to know the DP on your tips, all the important problems of DP, all the difficult problems of the DP, you should watch the whole playlist. Come on, right? So I've written all these things here. What I'll remove from here is I can simply remove these base cases because these are not going to occur now. I can simply remove these base cases, correct? I can simply remove these base cases. Okay. So, all right. This particular case, this is recall case. I can remove this as well. So we can remove this recall case as well. The last thing is that wherever I've written return statement, I have to save and return the answer itself, right? So here I have to save the answer and you can say continue. So if this is the case, right? DP of I comma j, I'll save the answer and continue, right? And continue, right? Here I've written a return statement. No, I will simply remove this return statement. I'm saving the answer already and continue will happen automatically because this is the last line of the loop. So I don't need to write continue here, correct? So I've removed all the return statements. The last and the final step is wherever I have returned this memo function, I have to replace this with DP array itself. So instead of this, I'll simply write what? DP of something something. What? I'm passing here I plus 1, j plus 1. Here I'll write I plus 1. Here I'll write j plus 1. And that is it. Here what will I write? I can comment this out. I will here write DP of I plus 1 j. That's it. Here what will I write? DP of I j plus 1. That's it. Correct. Correct. And the particular case is that, these can go out of bounds, right? I plus 1 can go out of bounds, j plus 1 can go out of bounds. This is a possibility that they can go out of bounds, right? So I have to handle these out of bound cases now, right? So in order to do that, I will refer these statements here, right? What are these statements saying, right? If both of them will become empty, right? Basically, in this particular case, both of them can become empty, right? So I'll write a ternary operator here. If I plus 1, basically, I'll just copy paste this if statement here. If both I plus 1 and those things are equal, I'll simply write a 0 there, correct? And to be honest, I can handle this a separate way, right? So what I can do is to handle all these conditions of going out of bounds, because I'm doing I plus 1, j plus 1. I can simply do is I can create a function, separate function. I'll simply write public int get dp of ij, correct? Get dp ij. I'll pass the dp array here. And I'll pass integer I and integer j here, correct? I'll like get the n, the length of string 1. So it is dp dot length, and length of string 2 is m is equal to dp of 0 dot length, correct? What I'll do here, I'll write these conditions here, correct? I'll write these conditions here. So basically what I'm going to do here, if I is equal to s1 dot this is n and j is equal to m, I'm going to return a 0. If I is equal to s1 dot length, I'm going to return m minus 1, m minus j. If it is equal to m, I'm going to return n minus I, correct? Right, I'm going to simply return 0 from here, right? Or I'll simply return dp of I comma j from here if none of them are out of bounds, right? And I can simply, wherever I'm handling this case now, I can simply write get dp ij. I'll pass the dp area, I'll pass I'll pass j. I plus 1 and j plus 1 here. Whatever I'm trying to access, right? Here I'm trying to access, you can say I plus 1 and j. So I'll write here what? I'll write here simply I plus 1 and j as it is. Here I'm going to access ij plus 1. So I'll simply write here ij plus 1, right? And this is how I'm going to handle all the uh, rest of the conditions as well. Return what? Return dp of 0 comma 0. This will actually contain our answer, right? Let's call this function directly, right? Let's call this function. I don't need to initialize this array like that. I'll simply keep everything 0. I'll simply return what? Return uh, tabulation. I'll pass the parameters. What is it? String s1, s2 and dp. Word 1, word 2 and dp. And now let's see how this code runs. Let's see. It's getting accepted. Shall I submit this? It's getting accepted, you can see. And these are all the solutions for this particular code. Recursion, memoization, tabulation, that is it, right? In this particular version, I had to make another function to handle the rest of the checks, right? It's not good to add 3 ternary operators nested inside each other. So I made use of a second function. I hope it is clear to everybody, right? So yeah, so this was the problem called delete operations for two strings. And with this problem, we have successfully completed all these string related important DP problems, right? If you have some other problems which are string related and you have doubts, you can definitely mention those in the comment section. I can think of making videos on them as well, but actually these are all the string related problems which are very important, right? So I'll make a LinkedIn post about it as well, which in which I will list all these problems down. If you want to get a separate list, you can refer to that post. The link will be in the description once I make the post itself. So yeah, so thanks a lot for staying in this video, and I would like to thank like one of my subscribers is Coding Joysul, right? You are actually one of the best subscribers because these kind of like this particular subscriber is constantly messaging me to make videos back again, and like it actually motivates me a lot, right? Whenever I see someone actually trying to get me on track, right? So thanks a lot for pushing me, right, to make these videos back again. This is of course another thing to get motivated from, right? As a creator itself, right? It is actually a blessing to have subscribers like you all. So thanks a lot, right? I hope you enjoyed this particular lecture. After this string related DP problems, I'm going to cover the 6 very important problems which are buy and sell stock problems. Students have a lot of doubts in those kind of buy and sell stock related problems. So I'm going to make videos on them. So there are around 6 videos, right, which are coming up. So I hope you enjoyed this particular video. Thanks a lot everybody for joining, and hope to see you soon. Bye.